Now I know you can't wait to get started on this physics lesson, you're as eager as I am. However, you are going to need a calculator, so go and grab one now if you haven't got one handy. Density, everybody. It's not a new word, is it? I know you've heard it before, and you probably did some simple calculations on density in your previous learning. Have you ever wondered why oil floats on top of water? The simple answer is because oil has a lower density than water. But what does density actually mean? Density is the amount of matter within a certain volume. Density is defined as mass per unit volume. It is a measure of how tightly packed and how heavy the molecules are in an object. Your first question: which object has the highest density, A or B, and why? 15 seconds to decide. Time up. The answer is A has the highest density because the same mass takes up less volume. The particles are therefore more squashed together. You can see the same number of particles in A compared to B, but because there is less volume, the particles are more closely packed together, giving the substance a higher density. Let's try another one. Which object has the highest density here, and why? A or B? 15 seconds. The answer is B has the highest density because its particles are more closely packed together and because there is more mass in the same volume. You can see very clearly there are far more particles in B compared to A. I'm sure you've all heard the classic riddle: which weighs more, a kilogram of feathers or a kilogram of lead? As you probably remember, the answer is they weigh the same. You just need a lot more feathers than you do lead to make up the same mass. This is because feathers are far less dense than lead, so take up more space to make up 1 kilogram of mass. Let's have a little look back at the type of sum you might be familiar with. Previously, you will have learned how to find density by following these very simple steps. Number 1, find the mass of the object. Number 2, find the volume of the object. Number 3, perform the calculation. Density equals mass divided by volume. Let's have a look at an example. If the mass of an object is 35 grams and it takes up 7 centimetre cube of space, calculate the density. So have a go at calculating this now by yourselves. 15 seconds. If the mass of the object is 35 grams and it takes up 7 centimetre cube of space, the density is mass divided by volume. 35 grams divided by 7 centimetre cube, which gives the answer of 5 grams per centimetre cube. However, this is not Key Stage 3 anymore. This is GCSE Science. So we use exactly the same equation, but different units. So now we are measuring mass in kilograms, volume in metre cubed, therefore density is presented as kilograms per metre cubed. Okay everyone, now's the time to grab a pen and something to write with. You need to make a note of the equation that's about to come up because you have to learn it. This is the symbol equation for density that you need to be familiar with for your GCSE. So density is represented by the Greek letter rho, which looks a little bit like a lowercase p. Mass is represented by a lowercase m, and volume is represented by a lowercase v. In the example we've just used, the density of the object was 5 grams per centimetre cubed. Now we need to change this into the GCSE units. Instead of writing 35 grams, we write it as 0.035 kilograms. It's very easy to change grams into kilograms. There are 1,000 grams in every kilogram. So to change grams into kilograms, you just need to take the number and divide it by 1,000. And to convert centimetre cubed into metre cubed, we need to divide it by 100, and then by 100, and then by 100 again. So you're dividing it by 3 lots of 100. And this will give you the answer, 5,000 kilograms per metre cubed. It's worth spending a little bit of time on practising converting units. If we have 1 kilogram, that is the same as 1,000 grams. To write this in standard form, it's 10 to the power 3 gram. Now if we look at 1 metre, that is the same as 100 centimetres. Can you guess how you would write that in standard form? 10 to the power 2 centimetres. So the power tells you how many zeros you need after the 1. Standard form. You'll have heard of this in your maths lessons. We use it in science as well, you'll be glad to know, and it's very straightforward. We use a number that's between 1 and 10, and then we multiply it by powers of 10 to get to an either very large number or a very small number. Let's have a look at how it works in our example. To write this number as standard form, we do 5.0 times 10 to the power 3. To make 5 into 5,000, you would have to move the decimal place to the right 3 times. Oh, I think it's time for a little quiz. Sink or float? This one's rather fun. We have 5 items to look at. It tells you the density of each item, and moreover, it tells you the density of water. You need to decide whether each item will sink or float in water. Okay, it tells you the density of water is 1,000 kilograms per cubic metre. Now let's try item 1. It's bone. Density 1,800 kilograms per metre cube. Will it sink or float? 5 seconds. It will sink, everybody, because it's far higher in density than water. Next item, cork. Density 240 kilograms per cubic metre. Sink or float? 5 seconds. It's a floater. 240 is far less than 1,000 kilogram per cubic metre, so it will easily float. Item 3, diamond. Look at the density, 3,010 kilograms per cubic metre. Sink or float? Oh, it's sinking right to the bottom here. A very dense material indeed, far denser than that of water. Next item, ice. Ice is the same as water, but it's in its frozen form. The density of ice is 900 kilograms per metre cubed. Will it sink or float in water? 5 seconds. Yes, it floats. Ice is very unusual. It's one of the few substances that will be less dense when it's frozen. Last one, density of wood. 770 kilograms per metre cube is its density. Will it sink or float in water? 5 seconds. Wood will also float in water because its density is less than that of water. Did you get all 5 right? I hope so. Okay, it's about time we did a little practical work here. So we're going to use our density equation of mass divided by volume is density, and we're going to find out the density of 2 different objects. We're going to find out the density of this item. Second item is rather valuable. I need to be careful with this. It's lead crystal stopper from a decanter. Spot the difference. How do these 2 items differ? Well, they are the same in one aspect. They're both solids. However, if we look at this one, it is what we would call a regular shaped solid, whereas this item is highly irregular. So we need to use 2 slightly different methods to work out their densities. Remember, to work out the density of any object, we need 2 measurements. We need to know the mass of the object and its volume. Let's go and measure the mass. Don't forget to set the balance to 0 before placing your item on. As we've just seen, the mass was 68 grams. Next, we need to know the volume. This is very straightforward with a regular solid. We just use the calculation, length times width times height. So let's go and do that now. First, we measure the length, 7.5 centimetres. Next, the width, 7 centimetres. And finally, the height, 3 centimetres. So we have found out the length was 7.5 centimetres, the width was 7 centimetres, and the height was 3 centimetres. So to work out the volume, we multiply them together and we get the answer 157.5 centimetre cubed. Over to you now. You're going to use the density equation to do 3 things. Firstly, calculate the density simply in grams per centimetres cubed. And then the green task there, convert it into kilograms per metre cubed, and then to challenge yourself further, you can convert your answer to standard form. 60-second task. Time up. Let's use the equation density equals mass divided by volume, which is 68 grams divided by 157.5 centimetres cubed. This gives us the answer of 0.43 grams per centimetre cubed. Next, to convert to kilograms per metre cubed, we use the same equation, but you use these figures. So we divide 68 grams by 1,000 to get it to 0.068 kilograms. And to change 157.5 centimetre cubed into metres cubed, we need to divide it by 100 and then 100 again and 100 again. So you move the decimal point back 6 places. This will give you the answer 432 kilograms per metre cubed. For the final challenge, convert into standard form, you should have got this answer. 4.32, because this is a number between 1 and 10, and then you multiply this by 10 to the power 2. Now onto our irregular shaped object. Now this can be an awkward customer. The mass, however, is easy to do with the electronic balance. It's the volume that requires a different method. As before, we measure the mass with the electronic balance. Well, calculating the volume of an irregular object is all very well and good if you have a piece of kit that looks like this. It's called a Eureka can. Not many of us have one of these lying about at home, so instead we can use a regular measuring cylinder or measuring jug in my case. Let's go and measure the volume of our irregular shaped object. We have 350 centimetre cube of water in the jug. So I'm carefully going to submerge my object. You have to make sure there is sufficient water to completely cover it. And we can see that the water level has gone up to 450 centimetre cube. So the difference between the two levels is 100 centimetre cube. This is the volume of the stopper. Okay, time to put our numbers into the equation and calculate the density of our stopper. Density is mass divided by volume. The mass of the stopper was 285 grams and we divide it by the volume, which was 100 centimetre cube. This gives us the answer of 2.85 grams per centimetre cubed. I'm now going to give you 30 seconds to do the next steps yourselves. Convert to kilograms per metre cubed and then finally convert your answer to standard form. 30 seconds. Let's have a look then. 0.285 kilograms divided by 0.0001 metre cubed gives us 2,850 kilograms per metre cubed. Well done if you got that right. To change to standard form, we write it like this: 2.85 times 10 to the power 3. Well done everybody, time for your learning check. Multiple choice. Question 1. What is mass? How much space is taken, how much matter is present, or the weight of an object? 5 seconds. Mass is how much matter is present. Question 2. How do you calculate the volume of a regular solid? Length times width times height, mass divided by volume, length plus width plus height. 5 seconds. The answer is length times width times height. Question 3. What is the correct calculation for density? Volume divided by mass, mass divided by volume, or mass times volume? 5 seconds. Density is mass divided by volume. Question 4. What is the international unit of density? Kilograms per metre cubed, grams per centimetre cubed, or kilograms per metre square? 5 seconds. The international unit of density is kilograms per metre cubed. Final question. Which is the correct equation for density? Is it rho equals volume times mass, rho equals volume divided by mass, or rho equals mass divided by volume? 5 seconds. The correct answer is this one. Rho equals mass divided by volume. Congratulations everybody, if you've made it this far, you've got to the end of your density lesson. Time now for a little bit of fun, something you can try at home. You just need an egg and some water. Ooh, and a secret ingredient. Let's go down to the kitchen. Welcome to my trusted assistant, Mr. Jones. What are you holding?
An uncooked egg.
Okay, I'd like you, when I say, to put the egg gently into the jug of water. I want you firstly to tell me whether you think the egg will sink or float.
Sink.
Okay, let's see if you're right. Pop it in gently. Oh, yes, it's gone straight to the bottom. It's a wonder it didn't crack with that force. So I'm going to remove the egg for a moment. I'd like you to put a couple of really big spoons of salt into the water. So what he's doing now is adding particles to the water. The particles of salt will dissolve in the water and give the water a higher density. Let's see if he's put enough in to make the egg float. Okay, the salt's almost dissolved. Can you now have a go then at trying to put the egg back in, and this time see if it floats?
Oh, yes!
Yes! You can see here now that the salt has dissolved a little more, the egg is highly buoyant. I don't know about you, but I'm exhausted after all that. Get it? Egg exhausted? Oh, never mind guys. See you next time.